Wait, what? Either those chips teleported through the cover or I forgot to clean the ways before I installed this thing. Hello Internet, my name is Quinn and this is Blondihacks. I hate cleaning up my lathe and I'd like to keep chips off the ways to extend their life, so I'm going to make a way cover for my lathe right now. These are the ways on my lathe. They are prismatic ways, which means they have a lot of nooks and crannies where chips get in and get caught, and it's, well, generally a hassle to clean. And the trick with a lathe, of course, is that you need a lot of travel on the carriage. So a way cover solution has to exist in this space and also collapse into a very small area. It's not like over here on the mill where table covers are easy, just throw a piece of leather down there, job done. I did actually try doing this with a piece of leather that I have left over, and you can see how it wouldn't really work very well. It's going to bunch up and interfere with the chuck and otherwise not work very well. So you need something that's kind of designed to expand really well and compress into this very small area here as needed. Especially when using like the collet chuck, the carriage gets very close to the spindle nose sometimes. So a big pile of leather is just going to heap up in there, and that's no good. Conveniently, smart people have invented a high-tech product for exactly this purpose. You can buy way cover material from McMaster Carr, and it's an accordion high-tech textile of some sort, and it compresses down to very small size, less than an inch, and then it expands to over 12 times its length. So it's pretty cool stuff. It's like a plasticky textile of some sort. It's supposed to be immune to oil and chemicals, and there's also a heat-resistant version if you need that. So it's pretty cool stuff. So there's the brand there, but as I said, I got it from McMaster, hashtag not sponsored, and it comes in all different dimensions. To the scrap bin now to try and find some kind of material to make brackets from for this. I've got some chunks of aluminum here that might work, and yeah, I think one of these might do the trick. I'll make a bracket for the headstock here that uses that existing bolt that has a little chip cover on it. So I'm going to cut this to length. Now I want the way covers to be 6 inches wide, so I'll start by rough cutting this bracket a little longer than that with the hacksaw for character building. I'll set this up on some thin parallels so I can drill holes and such in it. Tappy tap tap that in. I'll square up one end here, and this will serve as my reference. The overall length of the rear bracket piece here is a little bit unknown because there's a tricky space I have to fit into here. This piece of sheet metal here is going to prevent it from being full length. So I'll measure the distance to that bolt there with my inside dividers, and that'll tell me where to put the hole. And then for the vertical distance, I just kind of stuffed some parallels and shims in there and approximated it that way. Then I transferred those dimensions to the stock from my reference edge. This is a generous clearance hole, so we don't have to be too precise with this location, but find that center mark with my center drill, and then center drill it and drill it through. I'll stop here and do a quick test fit because I might have to clearance the front edge of that bracket. These are prismatic ways, so the tops of the two outer V-ways are not the same height. So there might be some issues there, but that actually looks okay. Now the trick is the fabric is not going to be centered on this bracket. The bracket is off center. So I put my scale, which is the same width as the fabric, up on there and eyeballed the center of that so it's over the ways evenly, and then taped that in place and then transferred that length to the bracket and then milled it down to that line. Next up are some tiny holes to hold the fabric, so I'm grabbing a reference on the lower left corner there, and I'll spot drill those two outer holes there, evenly spaced from that reference. Remember, this bracket is not symmetrical. And then the center hole is one of the support holes for the fabric as well. And then I tap those. And deburr, make everything look nice. A little test fit with the hardware, that looks good. For the clamping plate, I didn't have the right piece of stock for that, but I found this piece of angled aluminum that is exactly the right thickness and length that I need. So I'm going to cut my strip out of this using the slitting saw. So by hand, I touch off on the top surface, then I crank it down to the width of stock that I want plus the thickness of the blade, and then proceed to run this across the stock. Obviously, this is a lot more fooling around than just using a piece of flat bar, but I didn't have the right piece of flat bar, and this way I don't have to wait for stock to be delivered, and I like to reuse these old scraps whenever I can. It always makes me happy when I can make an entire project with just effectively garbage that I had around the shop. And that remainder will go back in the bin for some other project. Now that scrap was too short for the bracket at the other end, so I have a different piece of angled aluminum that's the right length, but is a slightly different profile, and I can't cut it the same way with the slitting saw. So instead I did it this way. I spaced it up above the vise jaw with some parallels, and then ran an end mill all the way down the corner there at just the right width, so that I would be left with the strip that you see there. The trick is you have to do this without cutting on what's being clamped in the vise, because of course that won't be stable. I did get into trouble near the end here. See that vibration on the right end of the stock? That's keeping me from getting a good cut. The cutter's very unhappy. So I added some support to that loose end, put a toolmaker's clamp on the stable part of the stock, and then clamped the other part of the stock to that clamp, and then that stabilized it enough to finish this cut. Now I didn't get all the way through the stock, but luckily I didn't need to. I was able to get just the length that I needed here with those clamps to give me a little extra support. So I cut that chunk off of there with a hacksaw, and now I've got my two parts. I'm going to square up one end of both pieces, and that's going to be my reference end for subsequent operations. And then I'm going to clamp these two pieces together, square up the reference sides on them there. Once I've got my reference, now I can put a clamp on the other side. The two parts aren't going to be exactly the same width, so you always want to clamp the two pieces to each other and then clamp them in the vise. If you just try to clamp them in the vise stacked up like this, then one part will always be loose, because in the real world, two parts are never exactly the same size. And with all that clamped up, I can now center drill and then gang drill these parts together. These are the clearance holes for the mounting bolts. And I'll do a quick test fit by bolting that plate to the bracket that we just made, and that looks good. I'll be grinding those screws flush on the back there afterwards, but now I'm going to flip it over, and I'm going to use the other piece of flat bar that we made to level up the parallels. And here's a trick to get lined up on the existing hole there. Put the drill that made the hole upside down in the chuck, and then use the square end of the drill to line up on that hole. You know you're lined up when the drill does not deflect as it goes into the hole. And then flip the drill over and drill that through. This is like a medium precision method for match drilling a hole. It'll get you within 5/1000ths or so. Switching gears to focus on the carriage bracket now. This is a little trickier situation. I need kind of a T shape that goes down between the ways there, because up where the cover needs to go, the cross slide is there, and of course the cross slide moves, so I can't bolt to that. So I've got this big piece of flat stock. Now this is actually Alcoa Mic 6 or Mic 6 or MIC 6. I don't know how you pronounce it. Anyway, it's an interesting alloy. It's designed for like fixture plates and stuff, so it's precision ground. And I've got two factory edges on this that are really good. The stock was a donation from a viewer, hence the not my handwriting on it. And I thought I'd give it a try. It's a little bit on the thick side for what I need, but again, I have it, so I'm going to use it. I'm going to do this part with simple layout and milling to the lines, which whenever I can do this method I like to, because it's a lot of fun, less measuring, less edge finding, and very satisfying. So I'll mark out the far edge. That little curl there is artisan flair, totally meant to do that. And then I'll lay out the rest of the T shape here. And I'm using my calipers for this because it drives trolls crazy that I occasionally make light marks in bluing fluid with my calipers. There's a lot of material to remove here, so I'll start at the band saw. So assume the Summers position, and I proceed to rough this out on the band saw. And yes, I know the blade guide is too high. That's as low as it goes on these saws. This is just a temporary vertical mode that they have that you can take advantage of in a pinch, situations like this. Those of us with small shops don't have room for multiple band saws, and a horizontal band saw is a very, very nice thing to own in a machine shop. So it's nice that these cheap 4x6 band saws have a vertical option that you can use in a pinch. The bottom and left side of this are the factory edges, which are very good, so I'm going to use that as my reference, and I'm going to make the top edge here parallel. Once again, just milling down to the layout lines by eye. I really like this style of just milling to a line on layout fluid. It's a lot of fun and it's very efficient. Precision-wise, it's good to within 5 thou probably, if you're careful. You're trying to split the line in half effectively, and with a little bit of magnification, you can tell when you are there. It's worth noting that my layout lines here are a little thick, and that's because the layout fluid went on a little thick, so you get wider lines. The finer your lines are, of course, the more accurate this method is. Next, I lifted it up on a parallel to do the remaining sides. I was concerned the part wouldn't be rigid enough to do the top edge in this setup, so I did it in 2 setups. So So I milled those two T-surfaces there. Now for the vertical sides, I'm going to side mill them, but they're a little taller than the cutting flutes on this end mill, so I'm going to do it in 2 passes. So I start at the top and I mill to my line in this position, and then I've got my X established. With that cleared out, then I move the end mill down to the same Z value that I used for the arm of the T, and then mill out that little remaining corner there. And of course I still have my Z value for when I go to do the other side, and then the same procedure to mill down the side over there. There's one more economy I can get out of this setup, and that's to run down to the far edge with the rapids and side mill that other end there. The near end was a factory edge from the stock, but this edge was still a layout line, so I'll square that up. And that's looking good. There's the T shape. Now got a lot of deburring to do there. There's a lot of edges there. Now this Mix 6 or Mic 6 aluminum has a reputation for being difficult to machine, but honestly I couldn't tell the difference between this and 6061 aluminum. Seemed to machine just fine to me. They say this stuff is gummier, but I honestly didn't notice. Now I'll tap that in horizontally, and I'm going to lay out my holes. And I decided to just edge find this and center it up. For the Y position of this hole, I'm going to make it a slot actually, and I just eyeballed a good position based on the size of the drill that I'm going to use. And then same with the other end, I just eyeballed the end. The height of this thing is quite a bit of an unknown, so I'm just going to make it a slot and then it'll be adjustable. The hardware here is M5 by 0.8. I don't have a 5mm end mill, so what I'm going to do is drill the ends 5mm. That'll establish the ends of the slot. So that's going to be a nice close running fit there, as you can see. And then same thing at the other end. And then I'll chain drill in between to clear out the bulk of that material there. And then I can clear out that material with a smaller end mill. This is a 3/16 imperial end mill. It's a little smaller than 5mm, so I can run it down my center line of my slot. And that leaves me 8 thousandths narrow on this slot, so using DRO, I move 4 thou to one side, mill down that edge, move down the other side, -4 thou, mill down that edge, and then we're all set. There's an interesting little lesson in drill dynamics here. If you look at the finished slot, you can see the difference in tool marks where the drill went to versus the end mill. The drill marks are maybe 5/10 deeper than the milled sides are, and that's the wandering that drills do when left to their own devices. They always create a little bit oversized hole, and you can see that effect here. Now the ends of the slots don't show that discontinuity, and that's because those were center drilled. So you can literally see the benefit of center drilling or spot drilling when you want a more precision location and size. To get the screw locations, I'm going to clamp the clamping plate that we made to the top here using these Toolmaker's clamps, and then the inverted drill trick again to line up on the clearance holes, and then I replace that with the smaller tapping drill size to tap drill these. Now, of course, that tap drill might wander a little bit, but it's going to be close enough. It's a generous clearance hole, so I'm not very worried about that. And you'll note that in the center, I'm actually drilling through both parts. The center hole was never made for the other clamping plate because it uses the mounting hole in this position. The two clamping plates aren't exactly symmetrical, so I'm drilling that now. And I drilled out just the top plate clearance size after this. And those are all tapped through. If you've been paying attention, and this will be on the test, the other end of those clamping plates is still unmachined. So now I can bolt that in place and mill it down to match the bracket. There we go, perfectly matched bracket and clamping plate, and we basically didn't measure a single thing. It's always nice when you can do that. To mount this on the carriage, I set it on there, and this is effectively the lowest point of adjustment, so I transfer punched the high end of the slot onto the casting there in the carriage, and then that'll tell me where to drill and tap my hole. It's going to be tricky to drill straight down in there, so I drilled a hole through this piece of scrap with the tapping drill, and then I find the punch mark there with the drill, slide the block down against the cross slide, and clamp it in place, and we have a field expedient drill guide. This is cast iron, so of course it drills quite easily, so this is pretty straightforward. Luckily I was just able to get my hand drill down in there between the ways. I'm very glad I was able to do this without having to take the carriage off the lathe. Then I opened up that same hole to a clearance size for the tap, clamped it back in place, found the hole with the tap, and then ran the tap through, so my drill guide became a tap guide, just like that. I did have to manipulate the Tommy bar back and forth to get the tap in there. It was a little bit too low, but managed to get that done. Now my tap was a little too short to go all the way through the casting with the block in place, so I came back in and finished it up without the block. And then a little deeper, and that's done. Test fit with the hardware, looking good. Okay, over to this accordion material now. It's twice the width that I need because 12 inches is as narrow as you can buy this stuff. So I bought the 12-inch width, and luckily it's very, very easy to cut. I wasn't sure what exactly I would use, but I tried this single-edged razor blade first, and this worked super, super well. A little bit of sawing motion, and it cut through there no problem. Left a perfect edge. It's nice when that happens. And now I've got an extra piece that I might use for an additional way cover, perhaps between the carriage and the tailstock. We'll see. I'll put that in the drawer for now. I'll transfer the holes from the clamping plate to the fabric, and then I'll use my tack maker's hole punch here. My family are horse people, and horse people have these things lying around everywhere. It's a multi-size hole punch for leather, and it makes very clean, very nice holes in just about anything, because if you can punch holes in leather, you can punch holes in anything. Moment of truth. Let's see if all these parts clamp together. If I did all of my math right, this should all go together very nicely. So those bolts go on there. That's looking pretty good. So put the other end on as well, and you can see how cool this stuff is. It compresses up to a very, very small space, but then it can extend to a very, very long distance. So this stuff extends to 12 times its collapsed length, I believe, which is pretty impressive. All right, test fit on the lathe now, and let's see how that fits. And then stretch the other end down. I'm going to put that factory chip guard back in, might as well, just in case, but that looks really good. And I'll take that sticker off there because that's going to bother me. Okay, but how does it move? Because if it doesn't move right, then this was all for nothing. So bringing the carriage in, it does compress mostly very well. It does bunch up here right at the end a little bit. It looks like that's going to be okay. I don't think that will interfere with any of my chucks, but if that is a problem, I can try putting like some little weights on the accordion folds there, or maybe run an elastic string through some holes in the accordion. We'll see. But let's see how it does on full extension here. And you can see that when I'm all the way out, I've got full access to the bed, minus 6 or 8 inches here at the end, which honestly, I don't think I've ever had the carriage down that far. However, if I do need to get down that far, or for my faceplate, which will not clear this cover, I want to have quick releases on the cover so I can remove it when needed. So let's give the cover a test drive and make some parts over it. I've got some brass here, and I'm going to make some little knurled knobs that'll allow me to quickly remove and install this cover. Note that my knurl wheels are over center there, which is not how you should do it, but this knurling tool is a little too big for my lathe, and on smaller parts like this, I have to move the compound back to get the knurl wheels on center on the stock, and the compound was locked, and I couldn't find the Allen key, and yeah, it's not worth it. This was fine. And some chamfering there to make everything nice. And I went in part way with the parting blade, and then came back and chamfered that last edge. And yes, it bothers me that I switched chamfering tool in and out an extra time there. If I'd just done the part first, and then chamfered, and then finished the part, I could have saved a tool change. It always bothers me a little bit when I wasn't as efficient as I could have been. Good news is it certainly caught the chips, so that's encouraging. Let's see how easy it is to clean. It's a little bit floppy, so I tried a couple of different brushes, but you know, it's still easier to clean than the ways. Quick look underneath, moment of truth. Ah, look at that, spotlessly clean. I can install the quick release knobs at both ends now. That should be a vast improvement. Now there's a bit of an issue up here. You can see that there's a wedge-shaped gap there. It's because the casting is not at all square on the base of the carriage there. That little gap is going to collect chips, so I decided to fix that. This is precision Starrett gaffer tape. I found this at an auction. You can't get it anymore. But I'll just cut this to size, and then I'll take some of the extra length there from the end and double up the beginning there to create kind of a rough wedge shape. It looks 12% less like garbage. I'm not quite out of the aggravation zone though yet. The T-slots on my cross slide also always pack full of chips, and I've been living with this in misery for 5 years. So over to the 3D printer, and I printed some little filler blocks for those. Painter's 3-in-1 tool is the perfect way to neatly remove... Never mind. I printed those as single long pieces, and then I'll cut them to length to fit on either side of the tool post there. And that way there will be closed ends on the outsides and the inner ends will be open. Now you might be wondering, why am I cutting these to length instead of just printing them in separate pieces? Because the whole thing about 3D printing is that it prints the exact part that you want and doesn't require any post-fabrication steps. There's actually a really interesting and surprising reason for that. The reason that I did it this way is actually a really interesting subtlety about the nature of 3D printing and lathes. Now pay attention here, because this is really quite fascinating. So the reason that I did it quite exactly this way is because shut up, that's why. With the enclosed ends outward, I can slide all 4 pieces in there to fill those T-slots, and these are easy to remove when I want to use the T-slots for fixturing and such. Now that one piece there wouldn't quite go all the way in. The 3D print swelled a little bit at the end there, which sometimes happens, so a file dressed that up, and now it fits all the way down. And that is looking pretty sharp. No more chips in there. Now the one weakness still is the far end of the ways here. The occasional stray chips do fly over here. I could make another way cover between the carriage and the tailstock, but I'm going to leave that for now and see how much that bothers me. So there's the final result. I'm very happy with this. I think it's going to work really well, and it's going to help keep my ways healthy and the operator emotionally stable. So thank you very much for watching. If you like these videos, maybe throw me a little love there on Patreon. That's what keeps this content going. And I will see you next time.